In this video, we will translate graphs where we need to change something about the x coordinates. So I have 4 points graphed, A, B, C, and D, and this is the original function. And what we're going to do is we're going to draw the function that's translated from that, f of negative x. The negative sign in front of the x means that we're going to negate each x value. But we're not going to make any changes to the y values. So I'm going to use A prime to represent the translated point from A. And if we take the opposite of -3, which is the x-coordinate of the point A, that would be +3. So we're pairing that with 0. And let's go ahead and plot that. So that would be, actually it'll be in the same place as the original D, but I'm going to write A prime here. And then if we translate point B, we're taking the opposite of -1. That would be +1. And that's still paired with y value 3. So I'm graphing that point. And then if we translate C by negating its x value, we get -1 paired with -1. And I'll graph that and call it C prime. And if we translate the point D, which has x value 3, the opposite of that is -3. And that's still paired with the y value 0. And now what we're going to do is we're going to connect the points A, B prime to C prime, and C prime to D prime. Now if you stop the video and draw the original graph and then draw this new graph, f of negative x, what you should see is f of x has been reflected across the y-axis, but you'll need to stop the video and do that yourself. Okay, now the second thing we're going to do is another graph, and this graph is f of x plus 1. When you add or subtract something to x, it sometimes does the opposite of what you think. And the reason I say sometimes, if you also do a reflection, then it will, what we're about to see will be a little different. And I have a separate video where I've got a reflection of x as well as an addition or subtraction to x. So make sure you look at that video as well. But the trick that I always use that always works, if you've got something done to your x, so this would be in your parentheses with the function notation, take that expression of x, so here that's x plus 1, and set it equal to the x-coordinate of at least one of the points, and you'll see what happens to the x. So what I'm going to do is I'm going to subtract 1 from both sides, and I get x equals -4. And so the point that was -3, 0 is going to be translated to the point -4, 0. So let's plot that. Okay, I'm actually going to, on this graph, draw A so that we can view what happens as we make this translation. And A prime is at -4, 0. And so what you can see is that A has been translated to the left 1. So when we add 1 to x, we are actually going to shift the entire graph to the left by 1. And so if I shift the B value, which is at -1, 3, I'm going to draw that, but then translate it to the left by 1. I'm choosing on this particular problem to just show you geometrically what's happening for the most part, instead of doing algebra for every point as I have in another video. So B gets translated to the left 1, and so now it's at -2, 3. And C, which is at 1, -1, is going to get translated to the left 1 unit. And then D is at 3, 0, and so translate that to the left 1 unit. And now I'm going to connect A and B prime, and B prime and C prime, and C prime and D prime. And you can see, let me draw a little dash here at the original graph. Oops, I just did that wrong. Sorry about that. I meant to do B to C, C to D. I wish I could erase that. But I wanted you to see the shift to the left.